Welcome to my third year project. This is the wireless proximity defense system. First thing I'm going to show you is the main unit. Here we have a decoder, LEDs to show which sensor has been triggered, a transmitting LED which is here, and a low battery LED here. The microcontroller I'm using is the 8052 or 89 S52. Atomil is the maker of it. This is my LCD screen, and all the buttons I'll explain as we go along. The three sensors are here. This is sensor 1. This is sensor 2. That is powered by a PSU, so I can demonstrate the low battery. And over here I have sensor 3. I have them in kind of a 360 arrangement, just for demonstration purposes. So sensor 1 here is is powered by a battery, 9-volt battery, and there's a voltage regulator here, bring down to 5 volts. I have a spectrum analyzer here, so I can see if there's any or what transmission has been displayed. So my sensor here, when I put my hand in front of the sensor, the LED here will flash to show transmission. I've also cut an antenna the proper length for my frequency, which is 433.92 megahertz. So the speed of light over the frequency equals 1 wavelength, and I've cut it to a quarter wavelength, 17.3 centimeters. So as we can see on the spectrum analyzer, there is no nothing there at the moment, and as soon as I put my hand past the PIR, we have activity. Initial problems with the PIR is that if I swing it around here just to show, was the transmitter here part. The arrangement that was made up in other schematics and stuff like that is that the transmitter was always had power always going to it here. So I introduced a NOT gate into the system here, so I could be able to shut it off during transmission. So if I take it out here and I put it to where originally they always had it, here is that, and I turn back the PIR away from me, I can demonstrate to you what the problem was. Right, so looking at the analyzer here, the frequency analyzer, we can see here, look, that there's a frequency. It's constantly there, because not only is the I'll try and move this sensor close to the spectrum analyzer so you can see just what I'm talking about. You put the battery up there. As you can see, this is all planned beforehand. Right, this is probably better, yeah. So you can see here that like we have a frequency here, like this is no good, because this is like that the frequency is taken up. And so therefore my other sensors, this one couldn't, they wouldn't be able to transmit with that. So when I put my hand over the sensor now, you'll see that there's the increase. So that's when the sensor was triggered and the sensor is not triggered. Sensor's triggered, sensor's not triggered. So we had a problem with the transmitter always on, so I introduced a NOT gate. So if I put it back to my new design, like this, we can now see that the transmission is gone at that time after triggering it there. 1 second, I'm going to turn this away from me. The PIR keeps catching me. Right. So now we can. 1 second. PIR is catching me out. Right. So I was plugged into the wrong one there. I was wondering what was wrong. Right, so we can see here that the spectrum analyzer is nothing and PIR is not active. So now the new solution is that when the sensor is triggered, the transmitter is turned on through a series of NOT gates, and from the activation of the sensor, so we see no activity on the spectrum, and as soon as I put my hand over the sensor here, I'm going to try and show you. activity. Therefore, all transmissions can happen, and there's no blocking of the frequency. Right, so we'll move on to the actual body of the project, which is the receiver and microcontroller. Here we can see I have an alarm speaker. I have 4 switches here. These are for when I want to have the speaker on or off for each independent alarm. In a situation, if you wanted to be able to find the presence of someone but you didn't want to have the speaker active, you don't have to. But if you do want to have the speaker initialized when a sensor is gone off, then you can use each one of these switches to do that. There's a disarm button here. There's a reset or the learn button is here. This is so I can learn more sensors and encoders onto the system. I can learn 7 initially, and if I add EEPROM onto my decoder chip here, I'll be able to add a total of 32 devices wirelessly. Here I have link. Don't mind that. Yeah, too long to explain that to you. And here's a contrast button. So you can see from this, I can bring up and down the contrast, and this is my backlight, say nighttime mode. Right, so demonstration time. Each here in front of me on the screen, you can see Z1, Z2, Z3, and Z4. These are my zones. So I have each one of my sensors set to a different zone. I don't have a zone 4 at the moment, but all I wanted was 3 zones initially. But I added in the zone 4 because I might, add in a different type of sensor, maybe something resonance or window breaking, or I don't know. I haven't thought of it yet, but this is my 3 zones anyway. So the theory behind it is that when you activate, or when a zone is passed, and I'm going to pass zone 1 here, over here on the right, you should see zone 1 initially there. So this is zone 1 here. I pass zone 1 over here on the right. There. Let me turn off the alarms for a second. Right. So zone 1, and you can see the symbol coming up on the screen. Over to my right is zone 2, which I'm gonna put my hand over now. Zone 2. And to my left is zone 3. I'm passing it now. Right, so that's all the zones. You can see them lighting up each zone independently if someone passes by it. So then if you want the alarm to go off, I can select, right, I want zone 1 alarm to go off, I want zone 2 alarm to go off, but I don't want zone 3 alarm to go off. So when I pass zone 1, there's an alarm. When I pass zone 2, there. Zone 2 again, because zone 1 was still activated. Zone 2. And finally zone 3, which I said I wouldn't have an alarm on. So I should just be able to see a visible display that it's gone off. Right. I shouldn't have put the PIR so close to each other because I keep setting them off and walking around. Final test, low battery. These systems or these sensors can be really in a box unit, battery operated. Battery life is now prolonged because the transmitter is not transmitting the whole time. Therefore, I've saved something like 7.98 milliamps or something to prolong the battery. Therefore, the only thing that is draining power all the time would probably be the sensor, because the encoder is not active, is mainly in sleep until a sensor is activated. So, if these units are separate and are battery powered, therefore we need to know, if they're placed in a system, we need to know when the battery or when the sensor is going to go down. So quickly, I'm going to show you. Here we can see that I've this powered, this sensor 2 here is powered by a power supply unit, and I put on a voltmeter onto it there just so you can see the voltage in the circuit, because it's going through a 5 volt regulator. If I just up this a bit here, maybe 8 volts. It's okay. Here 8 volts is on the initial circuit, and going through the 5 volt regulator on the main circuit is 5.01 volts. So I want to reduce. First of all, I'm going to show you without the low battery. So I go back over here, sensor 2, zone 2 we're looking at, and I set it off by my hand, and we see zone 2 coming off. Turn off the alarm there. No, leave it on for there's zone 2. Now, what I'm going to go do here is, if I put this side by side, I'm going to bring down my voltage level. It's 3.8 volts. Of course, the voltage here would have to turn off. 3.8 volts. Right, so I'm going to bring this down to over here, 3.7, right? Now, one second, I'll try and get this right. .6. Right. Volts there. I'm running out of time. I'm going to make a second video.